Yes, class. So only 4 students have joined till now. Astha, Anushka, Imad, Liana. Alright, so in the last class, we had completed with the 4 cases that we have seen for the magnetic Lorentz force. Apart from this, we had seen force on a single conductor, that was BIL. Now, if 2 parallel conductors are there, please class start revising all these topics that we have covered last weekend and last to last weekend, because this chapter is almost towards the end. Next weekend you will have a test of the complete lesson. You had the test of a very small portion, now you'll be having a test of complete portion. Now see, if 2 parallel wires are placed, now what will be the force on one conductor due to the other? So see, first we have to find out what's the magnetic field. 2 long conductors are there. This is the first conductor, this is the second conductor. Length of both the conductors is same, that is L. I1 current is flowing through the first one and I2 current is flowing through the second one. And small d is the separation between the 2 conductors. So for a single conductor, it was BIL. For a single conductor, it was just BIL. Now, if 2 conductors are there, 2 parallel conductors are there. So for 2 parallel conductors, it will be something else that we'll calculate. It will not be BIL, just BIL will not work over here. So magnetic field due to the first wire at the second wire, what will be it? So we have done it in the last class. You had the test also, you had given the test. So we had seen that for an infinitely long wire, it's mu naught I divided by 2 pi r. So here current is I1, so it will be mu naught I1 divided by 2 pi. Instead of R, you have DO here. This will be the formula for the magnetic field due to the first conductor. Mu naught I divided by 2 pi r is the general formula. So R is small d. You are trying to find out the magnetic field on 2 because of the first one. Magnetic field will be generated because of the first conductor. So that is mu naught I1 divided by 2 pi d. Got it? Now you apply the force that will occur, force on second wire due to the first one. B1 is what? B1 is the magnetic field that is generated in the second wire on this point too. We are now calculating force on second conductor due to 1. So since it's due to 1, it means the magnetic field is due to the first one. Due to 1 means magnetic field due to 1. So F21 will be what? BIL sine theta will be there. Simply I'll write BIL only. This becomes ILB. Now see, current is occurring in the second wire because we are calculating the force on the second wire. So this becomes I2. Length of both the wires is same, so we can write it as small l only. And magnetic field is due to which? Force on second due to first. So magnetic field will also be due to the first. So BIL has been used. B1's value we already know from the Biot-Savart's law. So if you put in the value, F21 will be what? I2 L. Instead of B1, I will write mu naught I1 divided by 2 pi d. What is the formula of force on the second wire due to the first one? It's mu naught I1 I2 L divided by 2 pi d. This is the force on the second wire due to the first one. This is the force on the second wire due to the first one. Fine. If it is F12, means force on the first wire due to the second. So see, answer will be the same only. Answer here will also be the same. It's just that it will be I1 L and magnetic field will be due to the second. You will get the answer as mu naught I1 I2 L divided by 2 pi d only. Fine. So mu naught I1 I2 L divided by 2 pi d. This is the formula for force on the second conductor. This is which case? This is the case when both are parallel. Now see, if I divide this force by length, what will I be left with? Mu naught I1 I2 divided by 2 pi d. So this F by L that I am getting, I'll call this as what? I'll call this as force per unit length. This is force This is force per unit length. What have I done? I have just brought this a length in the denominator. So mu naught I1 I2 divided by 2 pi d is left, and force by length is force per unit length. So in the questions of force between two parallel conductors, no, two parallel straight conductors, if you have, question can be from force per unit part as well, and question can be directly from the force. If force is asked, multiplied by length. Even if length is given and force per unit length is asked, then do divide it by length. Per unit length, be careful whenever you are dealing with per unit length and only force. Now see, if somehow these two conductors, they are having the same direction of current, like in this case, they are having the same direction of current. So since the direction is same, they will attract each other. Whenever the direction of current becomes same in the two parallel conductors, they attract to each other. For example, two wires are there. Even if current is flowing downwards, they'll attract. Current is flowing upwards, they'll attract. They will attract if the current is going in the same direction. That direction can be any direction. It can be right, left, up, down, any direction. But if the direction is same, they will attract. If one is going towards the left, other is going towards the right, if the case is somewhat like this, both are moving in opposite direction. One current is moving upwards, other current is moving downwards. Then it will repel each other. If currents are in the same direction, conductors will attract each other. If the currents are in opposite direction, one upward, other downwards like this, then the conductors will repel each other. This is it. Regarding the direction of these two conductors, you have to remember this fact. So if conductors have current in the same directions, conductors attract each other. If they have the current in opposite direction, conductors repel each other. Now see, if you're calculating force on the second due to the first one, and you're calculating force per unit length on the first one due to the second one, two cases we can have, no, force on first due to second and force on second due to first. If you have such cases, they will be just opposite, equal and opposite to each other. Because from the formula, you can notice formula will be mu naught I1 I2 divided by 2 pi d for force per unit length. For force per unit length, this formula will remain same. By mu naught I1 I2 divided by 2 pi d. It's just that since in one case it will attract each other, in the other case it will repel each other, we just have this negative sign. So you can remember this. If by chance a question is asked, find force on second due to first and first due to second. So you can calculate one magnitude, put a negative sign for first, force due to first with respect to second, like this. One more thing that is asked, to define 1 ampere. See, 1 ampere, if generally it comes in your exam, it is usually from your current electricity. There you have to show that 1 ampere is what? 1 coulomb divided by 1 second. That is 1 amperes. 1 coulomb per second. This way you can define 1 ampere. Now here what will happen? If it is asked, define 1 ampere in terms of force between two parallel conductors. If this specific topic is specified to you, then see, how will we define 1 ampere? I1, I2 will become 1. Separation between both the conductors, that will also become 1 meter. Now put all the values for force per unit length. Mu naught is 4 pi into 10 to the power minus 7. I1 is 1, I2 is 1. This is 2 pi into D is also 1. So what are we left with? Pi gets cancelled, 2 into 2. So force comes out to be 2 into 10 to the power minus 7 Newton. Now how will you define it? Now you can say 1 ampere is that current that flows through two long conductors which are separated by 1 meter. Why are we writing this? Look at the formula that we have obtained. Force is 2 into 10 to the power minus 7. When are we able to obtain this 2 into 10 to the power minus 7? When you put separation between the wires as 1 meter and the current that is flowing in the wire as 1 amperes, then only you're able to obtain this force formula 2 into 10 to the power minus 7 Newton. So when it comes to define 1 ampere, you can directly write down that it's the current that flows through two long conductors which are separated by 1 meter and carry currents 1 unit ampere, and they produce a force of 2 into 10 to the power minus 7 Newton. This much. Got it? Any doubts till now? This is all about force per unit, and we'll do numerical, but before we do numericals, I'll ask you to first write it down. And let me know if you have any queries, any doubts from this. Questions, numericals do come from this.
Ma'am.
Yes, Asta.
Ma'am, in the numericals, if it's given long wire,
Hmm.
we should consider it as infinite.
Infinite, yes, infinitely long. If it's given a long wire, long means infinite only. In your solenoid we have done, yes, solenoid and toroid we have done in this batch.
Yes.
So even if it's given like long solenoid, it means infinite solenoid. When a long wire, infinitely long wire. Got
So
it? By
if
default,
it
it's
is
infinite.
infinite, they will mention that. I mean, when it is finite, they'll mention it.
They will mention for finite, semi-infinite, other cases it will be mentioned. By default, it is infinite, or if long word is mentioned, then also it's infinite. Got it?
Yes, ma'am.
matter.
चल
All right, let's solve this numerical. So this is formula-based numerical only. 2 ampere and 10 amperes current is flowing through the conductor. So they are flowing in the same direction. So direction also you have to write attractive or repulsive in the bracket. If you will write, that will be enough. Or you wish you can write a I cap, J cap, and K cap as well. Now force on second due to first and first due to second. So F force, okay, yes, one thing I forgot to write here. It's force per unit length actually, it's not force. So we'll use this formula where length was not there. Mu naught I1, I2 divided by 2 pi G. Mu naught is 4 pi into 10 to the power minus 7. I1 is 2. I2 is 10 divided by 2 pi into D is also 2. So 4 pi gets cancelled. This is 2 into 10 to the power minus 6. This is Newton, and I'll write attractive. Attractive will show the direction. Now for the second part of force on the first due to second, this is force on second due to 1. I need not calculate anything. Force will be negative. So F12 will be minus 2 into 10 to the power minus 6, and this is repulsive. Note it down, we'll do one more. One more question, important question is there. This was just formula. Note this down and we'll do the must have done by now. It was a short question, formula based, direct formula based question. Now let's see, this is one of the important questions. You have to calculate the force on the coil due to the conductors. And this time it's not force per unit length, it's normal force that you have to calculate. C class, one straight wire is there, that is I2, having current I2, and a rectangular coil is there whose length is L and breadth is B. Length and breadth of the rectangle are given, and the current that is flowing within this rectangular loop, this is I1. And the rectangular loop and the straight conductor, both of them have a separation of small t. Fine. Now we have to find out the net force. See, one force, if you just, let's break it into segments, A, B, C, D. Now, if you just look at AB segment, this is the first segment, look at this. Currents are in the same direction. This will attract itself, FAB. Now, regarding whatever the force will be on FBC and whatever will be the force on FAD, they'll cancel each other because everything, whatever they'll have the magnitude, both will be the same with opposite signs. So they'll be having zero value. So 2 and 4 will cancel each other. Regarding 3, if you look at CD's current is flowing downwards and I2 is flowing upwards in this wire. So it will repel. This will be the state of the currents, that is forces that are flowing. So net force will be due to FAB and FCD. FAB and FCD. These will cancel. So net force will be FAB plus FCD. Now FAB, just now forget everything that is written on the board except for AB and this wire. Let's name this also as PQ. So just focus on PQ and AB right now. In this case, you have done 2 wires are there. How will you solve it? So for FAB, yes, 2 wires are there. Asta, can you try it? Yes, this is one wire, this is another wire. How will you calculate the force? Look at the formula.
Ma'am, which 2 wires?
AB and PQ. Here current is I1 flowing, here I2 is flowing, they are separated by small d. What will be the net force?
Mu naught I1 I2 L by 2 pi d.
See, just L will not come because this is the length of conductor right now. And this is what?
Yes.
B. Fine, good Asta. So this will be what? This will be mu naught I1 I2. Instead of L, we'll have B divided by 2 pi d. And you can write minus I cap as well for the calculation. Now, this is your second wire CD because these 2 wires have their forces cancelled. So this is wire CD and this is wire is E2. Imad, can you try once? Imad.
Yes, ma'am.
Just try for this wire CD and PQ. What will be the force? Mu naught. Start with mu naught.
Mu naught.
One current is I2, second current is I1. So it will be
Mu naught I1
multiplied by I2. See, main formula is what? Mu naught I1 I2 L divided by 2 pi d. Now you just have to fit in all the things in this formula. This is the main formula. So mu naught will be there. I1 I2 are the currents. Now, what is the length of conductor CD? What's the length of the conductor CD? You must look in the figure. The rectangular part CD. What's the length of it?
B.
B. Yes, right. That is mu naught I1 I2 B. I agree. Divided by 2 pi d. What is the separation between CD wire and PQ wire? L is still here only. This total length, this is what? Look in the figure. L is still here and this is D. So total will be
P Q AFED.
No, forget the force. Just look at the length. This is small d,
Yeah.
and till here this is L. So what complete distance this will be?
AD.
Don't look at these A, D, and all these. Just look at this part. You have to, in the denominator, no, that we put as small d. What do we write? We write small d as the separation between the two conductors. Fine. So somehow in the earlier case, no, when we were talking about the conductor this AB and PQ, it was mu naught I1 I2. Instead of L, we had small v divided by 2 pi d, because d was the separation between these two. So we wrote this as d. Now we have this conductor here. So this complete distance will be what? It will not just be D, or it will not just be L, because both are here. D and L both are here. So it should be
2D.
D plus L.
D
Got
plus
it? D plus L. This complete. Got it? Till here it's L. This is D. So complete distance will be D plus L.
Okay.
Okay. Got it? Okay. Razan is also right. So complete answer will be what? Complete answer will be mu naught I1 I2 B divided by 2 pi D plus L over here. And the unit vector we'll put as I cap, because this is repulsive. Both are having the currents in the opposite direction. So this much is there. So you can, in the figure, you can get the values also. You can put it. Till now, you can leave it this way. Understood? How have we got this? Anybody has any doubt in any of this? I'll repeat. Let me know. Do one thing. First, note it down. If you're not able to understand, then ask me. See, magnetic dipole, you have the way you had electric dipole in case of electrostatics. Dipole is what? Dipole is a set of two charges which have the same magnitude but have the opposite direction. So plus Q minus Q comprises your electric dipole. Minus 2 microcoulomb plus 2 microcoulomb comprises your electrodipole. But if you have 2 coulomb and 2 microcoulombs, that will not make your dipole. Or even if you have plus 2 coulomb and plus 2 coulomb, that does not make your dipole. For two charges to be considered as dipole, you have to have one as positive, other as negative, provided that they have the same magnitude. So if it's plus 2 coulomb, it has to be minus 2 coulomb. Plus 4 coulomb, minus 4 coulomb. 3 millicoulomb, minus 3 millicoulomb. Like this. That was electrostatics. Now coming to magnetism, magnetic dipole will obviously exist because two poles are there and magnetic monopoles do not exist. So in any ways, you have magnetic dipoles with you. Now current carrying coil is there. This portion of magnetic dipole we will study when we'll do AC, alternating current. Before that, we'll do it in EMI also. We have Lenz law. A topic is there, Lenz law. There you have magnetic dipole and all these directions. But magnetic dipole, before we go into the next lesson, let us do it here a little in detail so that we can rush off there. Because now upcoming chapters after this, I think today will be the last class or tomorrow some time will be taken and your next lesson will be started because very few topics are left from this lesson. Then now all the upcoming lessons are very short. During one weekend batches that we have, your lessons will get completed almost. Especially this next chapter will be completed in the next week. That's why I had taken time in this lesson because this is a lengthy and it has all the basics. Just the direction of current by the polarity, how can you predict without using your right hand thumb rule? You can use your right hand thumb rule, that I'll tell you, but without using your rule. Supposedly, I say this coil has south polarity and this coil has north polarity. So for south polarity, do what? Draw S, and wherever the S has its end, draw the arrows. This gives you the direction of the current in the coil. Whatever is the direction of arrows, that becomes the direction of coil. For north pole, write N. Write a curved N, and at the end of the north N letter, put the arrows. See, these arrows will give you direction of current. Like this also you can predict. Magnetic dipole is given by, this is also a vector quantity obviously, and this is given by area into current. This is the formula. You don't have any derivation for this, just remember the formula. Current and this is area. This is magnetic dipole. Now, if n number of turns are there, it's not necessary that a single loop will be there. So if m number of turns are there, that becomes n into ai, where n is what? N is the number of turns in a coil. Number of turns, amount of windings that have been done. Fine. Now your right hand thumb rule comes. The right hand thumb rule, we have already done this. You have to curl your finger along the sense of current. Thumb will give you the direction of magnetic field. Curl your fingers along the sense of current. Thumb gives you direction of magnetic field. This we have already discussed. It's just a recap and a revision. Wherever the current is moving, curl your fingers in that manner. If it's moving anti-clockwise, curl your fingers anti-clockwise. Thumb gives the direction of magnetic. The reverse is also possible. If you have magnetic field outside, see the curvature of fingers. This is what this is, anti-clockwise. If this is the direction of magnetic field, this is the curvature of finger. That is giving clockwise. So both ways you can do this. We have discussed. If you still have any doubts, ask me. I'll repeat this. Question. See, a circle and a square are given. A circle and a square. Now, magnetic dipole moment will be NAI. So magnetic dipole number of turns are given as 100. Area will be pi r square. And current is how much? 2 amperes, no? Current is 2 amperes. In both the coil, it is 2 amperes. Fine. So pi r square, you can do one thing. For pi r square, no. Just write the value of pi. No need to simplify it. This is 10 to the power 2 into 3.14. Radius square will be 1 because radius is given as 1 meter and 2 amperes. You can even solve it further. This becomes 6.28. That is 628. Yes, SI unit I have forgotten to tell you. Current multiplied by area. So current's SI unit is ampere and area's unit is meter square. Like this. So this was one figure. For the second figure, M will still be equal to NAI. Number of turns are 100. Length square, because this is a square that is given multiplied by current. So this is 10 to the power 2. Length square is 4. Current is 2. This is how much? 800 ampere meter square. This is the magnetic dipole. So easy, a very short topic. Got it like this, you have to write. This is the magnetic dipole. Short, easy topic, I'll repeat. Magnetic dipole moment for the polarity. If you want to find out direction, write SN at the tips, draw the arrow. That curvature of the movement of the arrow will give you the direction. So you need not remember anything. Formula is AI for a single turn and NAI for a number of turns. Curl your finger along sense of current. Thumb gives the direction of magnetic field. This you have already studied, and 2 easy numericals from this. Area of a square, area of a circle, you just have to multiply. Fine, note it down. Again, any doubts you have, I'll repeat from any of the topics, even from the previous topic as well. Now, before we have conversion of galvanometer, moving coil galvanometer, we have a very small topic, that is torque. So after this, we'll do that.
Ma'am,
Yes, Anushka.
ma'am, for these questions as well, we should mention the direction in the end, right?
Yes, directions do mention. If in the question, like in your tests that you had done, there 1 or 2 questions were specific, like give the magnitude of the magnetic field. There no need to write it. If you can write, you can write. If you have forgotten, it's okay. But if nothing is mentioned, if it asks you to mention magnetic field, SI unit, direction, by default you have to write. Because in your subjective questions, there are chances of losing because you don't know which examiner is taking your question. Got it?
Yes, ma'am.
Asta, are you asking something? Asta.
No, ma'am. ma'am.
Yes, say.
Ma'am, the small m and capital M both are for magnetic dipole moment.
Yes, actually it's capital M only. In certain books you will find it as small m, in certain books you will find it as capital M. So I write it as capital M only. By mistake I had written it as small m, because small m will use it for magnetic strength that we'll see in the next lesson. So write it as capital M only.
Okay, ma'am.
Done?
Yes, ma'am.
Yes, ma'am, done.
Ma'am.
Very small topic. Torque is there. Torque on current carrying conductor. Again, torque will be used again also. So all those topics that are important for the upcoming chapters that I am also telling you side by side. The way magnetic dipole, especially that polarity part, is very important for your EMI, electromagnetic induction, the chapter number 6 of NCERT. And torque we'll do again in chapter 5th. Chapter 5th, no, chapter 5th we'll do it in a comparison form. Now see for the torque, what's the formula of torque? let's supposedly, this is a coil. Rectangular coil is there, fine. Length of the coil is L and the breadth of the coil is B. Before this, no, I'll draw magnetic field, otherwise this will become confusing. Now magnetic field lines are there. Now see, length of this coil will be L and the breadth of this coil will be B. This will be, this is L. Now the magnetic field line will also be making an angle with the plane. For example, if this is your magnetic field, this is your magnetic field. This is your magnetic field and this is the coil. So coil and magnetic field will be making an angle that you will be able to notice here, this angle. So here also this angle will be made. Theta. Got it? So B is what? B is the magnetic field line, which is uniform magnetic field lines. L is the length of the conductor. B is the breadth of the coil. I is the current that is flowing within this. This is the current I that is flowing within the conductor. Number of turns that are present in this are N, and theta is the angle between the plane and the magnetic field. This angle between the plane of the coil and the magnetic field line. This angle. All right. Now see, when we'll calculate all the forces, no, let's write A, B, C. Magnetic field line is there, your current is moving. Fine, current is moving. So if you use your right hand thumb rule, let's take for this DC. Current is moving, magnetic field towards the right, force is upwards. So here the force will be applied upward. This is FDP. Current downwards here. So current will be towards the outside. This I have drawn it slightly tilted. So this becomes FA. You can do it on your own also. Here this is your current direction. This is your magnetic field direction. Force downwards. This is FAB. And this will be what? This will be FBC. All the forces are this. Now, if I just draw the downward portion, so here what will happen? At one point it will appear, just one segment of the wire. A is random, let me not choose it as A. B is the base that I have taken, the breadth of it. Now see, B side, the lower portion I have chosen. So at one point current is entering and from below point current is moving. So at one point current is moving up, other point current is moving down. That has been shown like this. Now if I draw a perpendicular from both the sides in the form of right angle triangle, this part will be B sine theta. Why do I have to draw? Because I want to calculate the torque, and whenever we calculate the torque, for calculation of torque we require R perpendicular. Torque is always R perpendicular into force. You cannot take or choose the length B, because B could be slanting, B could be slightly tilted, B could be at any random angle. We have to have the perpendicular distance. So that's why we have expanded this to find out what is this distance. This was your conductor. Here the conductor was there. That rectangular conductor was above B. I have drawn this separately because on that diagram it will become very unclear. So this part will be B sine theta. Now torque will be what? R perpendicular is B sine theta into F. Now F, if you talk about, it will be what? This will be B I L. Fine. Now combine certain terms. Forces, this is force, this is R, so RF. Angle will be 90 degrees because you can see magnetic field line in the plane, they are always perpendicular, they are perpendicular to each other. So this becomes, for this case specifically, but we are talking about general right now, so let's consider it as theta. So this becomes BILB sine theta. Fine, I have just rearranged the terms. 90 degree it will be when the length and the plane of the magnetic field and the plane will be perpendicular. Here we have chosen an angle theta for every case, that all the cases that are possible. Now length into breadth will give me what? Area of the coil. So this becomes BIA sine theta. Number of turns that are present, NABIB sine theta. If you look at this carefully, A into I, this is magnetic dipole. Just now we have studied this. So it is MB sine theta, or you can write it as M cross B. Because sine theta is written when two vectors are there, and for n number of terms you can multiply it by. This is a very short derivation, but this can be asked to you. So I'll repeat. Net force I have taken, net force will be 0 because all the forces will cancel each other. So there won't be any translational force. All the translational force means through which the coil was pushed. Translational force does what? It moves the body, pushes the body. When you apply force over an object, if I'm applying force over here, it will move. This is known as translation force. Since you can see all the forces are cancelling each other, there will not be any net force. But a torque will be there. The coil will rotate. This motion of coil is restricted, but this motion of coil is permitted. Torque is there. This motion of coil is not here because net force is 0. So all the forces will cancel each other from all the sides. So it will stay at its position. But rotational force exists, torque exists. So there will be rotation of the coil. It won't move. If there had been a translational force, normal linear force that here, then it would have been doing like this. But since no translation force is there, rotational force makes it rotate. Now here for the expansion R perpendicular, you have to choose. So you just have to drop the perpendicular till here. That perpendicular I have shown through this figure. Fine, this perpendicular I have taken. And if you apply your Pythagoras theorem, your trigonometric rules, this side becomes B sine theta. So R perpendicular is what? R perpendicular is B sine theta. And what is your force? Force will be BIL. Yes, Amath. You can. Right now you have to? You can.
Okay.
It's now major portion has been completed of today's class. You can join tomorrow.
Okay, thank you.
And then torque will be what? If you simplify here, a current, you will be left with NAIB. AI is magnetic moment. So it's the cross product of magnetic dipole moment and magnetic field. In case of electrostats, you had P cross E. Electric dipole moment into electric field. Here you have magnetic dipole moment into magnetic field. So this way also you can remember it. Fine. And these are the 2 points. Net force on a current carrying coil in uniform magnetic field is 0, and it is independent of shape and size of the coil because area is there, you are not concerned with what is the shape of the coil. Torque will not change, even if it's a square or a circular loop. Torque will be independent of it. This is just a theoretical point. Net force is zero, net torque is not zero. Translational equilibrium is there, but rotational equilibrium does not exist over here because rotation torque is there. Got it, class? So it was a very, very short topic in this. Just note it down. This derivation can come. The small derivation, the 2 markers or 3 markers, it can come along with the numerical. See class, this was torque. Now one last topic is left, that is conversion of basically moving coil galvanometer is left. So rest of the things we'll do it in the next class, the construction and the sensitivity and the formula. But at least just get to know what is a moving coil galvanometer and its principle, because these two things are very easy to learn. Because right now only you have understood torque. Moving coil galvanometer is basically a device that is present to detect current. It has a pointer, and if the current flows in the circuit, then there's a deflection that is shown by this. Either it will move in clockwise direction or anti-clockwise, towards left, right, wherever. But that deflection, even a slight deflection in the galvanometer, will predict you that yes, current is there in the circuit. If no current is flowing in your circuit, there won't be any deflection in the galvanometer. What is this pointer? How is it moving? We'll study it tomorrow. So it's a device which is used to detect the current. Now, principle is basically that whenever a current carrying coil is placed in magnetic field, you have a current carrying coil, this is placed in magnetic field. Speciality is that the magnetic fields are radial. We'll see this. So a current carrying coil is placed in magnetic field, it experiences a current dependent torque, and this torque rotates this magnetic field. Let's do the construction. Without construction, you'll not be able to understand the principle. See, till here, let's do it today. Construction is basically, see, two permanent magnets are there. These are permanent magnets. A pointer is there. A pointer is connected on this soft iron core. This is basically soft iron core. This is spring. And on the spring, a pointer is connected. These are permanent magnets, and outside you have a scale. Scale has all the measurements. Now, this is concave side of it. Concave magnets are existing. So because of this curve, the magnetic field lines that are coming are radial. Radial means in the direction of the radius of the circle. Fine. Now what happens? Because of current that occurs in the circuit, because of current in the circuit that occurs, here what happens? Here, because current exists, and what we have studied, a torque will exist here because of the circular magnetic field that are existing. A torque will occur. Now, torque's function is to rotate. It's rotational analog of force, so its function is to rotate. So what will it do? Because of these radial magnetic field lines, current has been produced. Now, current will produce a torque, and this torque will try to rotate it. So the pointer will rotate. But if there is no current in your circuit, then there is no torque produced, there is no rotation of spring, and the pointer will not show any deflection. Now, how do you see it outside? A device is there, a galvanometer device is there. It has pointers, it has scale, and a pointer is there. Now what happens? This part you are able to observe. So you are only able to see this part, scale with the pointer. The rest of the composition you're not able to observe. So if current exists in space in your circuit, torque will be produced that will rotate the pointer according to the intensity. This deflection will occur. If there is no current in your circuit, no torque will produce, no rotation will occur, and it will not show any deflection, and you will be seeing a static position. So what's the principle of it? This is the principle only. A current carrying coil that is placed in magnetic field, it experiences a current dependent torque that tends to rotate the coil and produces angular deflection. Got it? This is the principle of moving coil galvanometer. And whenever question is asked on moving coil galvanometer in your subjective questions, you have to show all these: construction, principle, working. Sensitivity is also there. Sensitivity, we'll do it tomorrow. So note it down here. Till here, if you have any doubts from any of the topics, let me know. So tomorrow we'll wrap up this lesson, and then your now syllabus will move on fast. because now till EM waves your lessons are short before we move on to optics. Text me done in the chat room when you've written all these.
Ma'am,
Yes, Anushka.
ma'am, my midterm exams will be starting from 10th October. So for that, the revision classes, when can I expect them to start?
What is your syllabus, Anushka?
Ma'am, I've sent all the details and all to the lady.
On the WhatsApp you've sent me?
Ma'am, not to you. The
The management you have sent. Okay, do one thing. Just on WhatsApp, no, either on the group or personal on my number, just send me those. What is your syllabus? So I'll let you know accordingly.
yes, ma'am.
Okay, and others also, if you have any queries regarding your midterms and half yearly exam, just let me know. Because in some other batches, other topics are done. So if any topic is going to come that is in advance, we can have accordingly to it. And so all those who have done, I think most of you have completed writing portion. So all those who have done can leave. Tomorrow we'll try to complete this lesson. And please start revising this lesson because you will have a test on the next week. Okay, thank you so much, class.
Thank you, ma'am. Bye, ma'am.
Ma'am?
Yes, Razan.
No, ma'am, Astha.
Oh, Astha. Yes, Astha. Say.
Ma'am, my exam is this coming Tuesday.
Coming Tuesday. Which date, Astha?
It is 21st, I think, no, 20.
Okay, and what's the syllabus?
The first 6 chapters till electromagnetic induction.
Till EMI it's coming. So you have it on Tuesday, 20th.
Yes, ma'am.
Okay, so 5th and EMI is coming. You have told me so late, Astha. In one batch, EMI has been started, so you could have completed in that batch. Fine. So see, chapter 5th is very easy. Chapter 5th we'll start with tomorrow, and I'll help you with chapter 5th. Regarding EMI, I can send you the video lectures of it if you wish from one of the batches. So any topic that you find it, because it's a very short lesson. So if you find any difficult, because very less time is left now. So if you want the lectures, you can skip up to the portion and just see the major things of it. Okay.
Yes, ma'am. This chapter also few numerical doubts I had. Tomorrow I have exams. So like after that, after tomorrow's class, I think you can like help me with the numericals, the textbook numericals for this chapter.
NCERT numericals. Did you send me some questions on WhatsApp?
No, I didn't send. I didn't start solving. I was studying for other exams, like other
Okay,
subjects.
okay. For the subjects. No, okay. After your exams are over, whenever your exam is due, tomorrow or whenever, just let me know whatever doubts you have. Or you can do one thing more, Astha. You can, whenever you have doubt, no, while solving, you can send me the picture of the doubt immediately that time. So obviously, I'll not be able to solve that doubt. Maybe I'll not be able to solve that doubt immediately on that time if I'm not available. But otherwise, I'll see your doubt on WhatsApp and it will get clear before the next class. Otherwise, you have to wait for one more weekend or for tomorrow's class. So that you can also do one more thing. On WhatsApp also, you can send the picture of the text, numerical, whatever you are having difficult, and let me know.
The doubts mostly are related to like the direction, like vertically upwards and downwards. The few starting questions of NCERT are that. So I'm getting confused in the direction. But the magnitude, the formula and all is easy. About the direction. So like tomorrow after class, like 10-15 minutes, could you like explain the
Okay, yes,
directions?
sure. I'll explain you in whichever directions you're mainly having difficulty. No, okay, I'll explain you the directions.
Okay, thank you, ma'am.